main engine start. 7, 6, start.
How do we know the reliability of a space shuttle rocket booster?
And liftoff. Liftoff.
How do we know whether pollution in the Chesapeake Bay is getting worse over time? How do we know whether aspirin helps reduce the risk of heart attacks? We know the answers to these questions in part because we have a rigorous system for finding things out. That system is called statistics. This series will introduce the basic principles of this system. Our exploration of statistics will take us inside factories, into laboratories, out on the street, and even underwater, because these are where the problems are. And so these are also where statistics are invaluable. With this unit, we introduce statistics as a way of finding things out. We'll see that statistics involves three broad activities: describing data, collecting data through experiments, surveys, and other means, and drawing appropriate conclusions from the data we've collected. These three main activities in statistics are similar to the things anyone might do to solve a puzzling problem. First, you need to describe the problem clearly. Since data are the raw material of statistics, we call this step describing data. Once you fully understand a problem, you can ask specific questions. Answering those questions often requires that you find out new things. That means you often need to produce new data, and that's the second step. Finally, you need to draw conclusions from the information you've gathered. This can be a tricky step, but statistics is a sure guide. By understanding and obeying sound statistical principles, you can separate speculation from firm knowledge. You can have confidence in your answers, whether the answer is the reliability of a space shuttle component or the rate of pollution in a bay. Now let's take a closer look at each of these steps. Lightning. It can be beautiful, but it can also be deadly. No one can yet predict exactly where lightning will strike next. But we do know a lot about when lightning strikes, thanks to research conducted by Raul Lopez.
In 1 year, we collected 750,000 flashes in just a limited area here in Colorado. So we were overwhelmed. I said, well, what do we do with it?
What Lopez did was to describe this data with a chart that graphically displayed when lightning occurred during each hour of the day. The completed chart was surprising. The majority of lightning storms in the region studied began within a couple of hours of noon and never at night.
I think we're in a position now where we can start saying, well, if we're going to have some lightning, it's probably going to be occurring in this region of the mountains, and around the peak activity is going to occur around this time.
Sarah seems like a perfectly normal, healthy young girl. But as her doctor charted her growth rate over the years, he became worried.
During the earliest years of life, so up to about age 2, her growth rate was close to normal. After that, her growth rate fell off rather strikingly, so she started to have absolute growth points below the normal range on the growth curve.
By describing the data of Sarah's growth, Dr. Reiter caught a growth deficiency before it became a problem. Sarah began taking shots of synthesized human growth hormone. It's no fun getting a shot, but Sarah's growth has returned to normal, a fact borne out by a later measurement of her height. Off the coast of Florida, statistics is helping save the lives of gentle creatures called manatees. Manatees like to float just below the water's surface. That habit makes them the unwitting prey of powerboat propellers. Wildlife officials in Florida charted the number of powerboats registered each year and the number of manatees killed. By describing the data this way, they saw a clear trend. More boats meant more manatee deaths. As a result, Florida created coastal sanctuaries where powerboats are off limits and the manatees can float freely. The second major activity of statistics, producing data, is widely used in efforts to control pollution. This is a fishing boat, but these fishermen are trolling for data, not fish. They're measuring the damage done by pollution of the Chesapeake Bay.
You can use monitoring data and trend lines or just regression lines to assess whether things are getting better or worse.
The back-breaking work of producing new data follows a precise statistical plan. Random samples of mud are skimmed from the bay floor. Clams and worms living there are collected and brought to a lab for study. The health of these creatures reveals the quality of the water in which they live. The data produced by these workers helped spark new laws that are protecting the Chesapeake from further pollution. More than 500,000 Americans are killed each year by heart attacks. Some doctors thought that ordinary aspirin might help prevent these deaths. But no one could tell until a statistically rigorous study was conducted. More than 20,000 doctors were recruited in order to produce enough data to draw sound conclusions. The doctors were randomly divided into two groups. Half received the treatment, an aspirin tablet every other day. The other half took a placebo, a harmless pill disguised to look like aspirin.
There were 104 total heart attacks in those who were assigned at random to aspirin, and there were 189 heart attacks for those assigned at random to placebo.
That's a 45% reduction in heart attacks for the doctors taking aspirin. The data was so striking that the experiment was stopped early so that everyone could take advantage of the new knowledge. One of the most common ways to produce data is a poll or survey. The results aren't always welcome.
I discount these polls.
But polls are a potent force in modern society. National surveys sample just 1,500 people to assess what 250 million Americans think about politicians, products, and problems.
Do you favor or oppose the death penalty for persons convicted of murder?
I oppose it.
Okay. In general,
But producing reliable results from polls requires meticulous attention to statistical principles. For instance, interviewers must be carefully trained so that they don't influence the responses they get from their subjects.
Then is it okay to probe and say 20 times, 30 times?
You suggest an answer?
Well, is it? Is no?
No.
Okay.
Absolutely. You never suggest an answer.
But when properly conducted, polls and surveys provide information impossible to get
We're
otherwise.
being held today. Would you vote for George Bush?
January 28, 1986. The shuttle is ready for another routine launch.
And liftoff. Liftoff.
1 minute 15 seconds.
Challenger tragically reminded us of the ever-present risk of space travel.
All operators, contingency procedures in effect. Don't reconfigure your console.
After the accident, NASA re-examined joints in the shuttle's booster rockets. Although each individual joint had better than 97% reliability, probability calculations showed that 6 joints working together were much less dependable. Such probability calculations are a key part of producing data and played a major role in getting the shuttle back into space.
3-0 and liftoff. Americans return to space as Discovery clears the tower.
Roger, roll, Discovery. Control program, Houston now controlling.
Once data has been described and produced, it's time to draw conclusions. When drawn in a statistically responsible way, such conclusions can be very powerful. Matt Perez is a crack-shot agent for the FBI. He's also Hispanic, a fact that should be irrelevant, but which wasn't in the early 1980s. Perez and over 300 Hispanic agents took the FBI to court, charging discrimination in promotion, assignments, and disciplinary actions.
People were being put into what we call the taco circuit, meaning the trenches, the work that was not career enhancing.
To support his case, Perez and his lawyer used statistics. They drew the conclusion that the pattern of hiring, firing, and promotion at the FBI was extremely unlikely to have happened by chance alone. Their analysis persuaded the judge, who ruled in favor of Perez, and ordered the Bureau to establish new policies to correct the problem. Originally designed to help, welfare has become a trap for millions of women.
I walked around depressed all the time. I mean, really, you run out of food, you know, I mean, it's terrible.
But an experiment in Baltimore showed that welfare could be improved. A group of welfare recipients was divided in half. One half went through the existing program. The other half participated in a new program called Options.
How much is your food stamp grant?
At Options, the women received remedial education classes,
$5.50. No, that's incorrect.
counseling, daycare, and job training. The result? Women who went through the Options program found more jobs and received better pay than the women in the existing program. Congress drew on these conclusions in new legislation to reform the welfare system. These are the kinds of stories you'll encounter in your study of statistics. Such stories illustrate how the three activities of statistics, describing data, producing data, and drawing conclusions, are used constantly to solve a vast range of real-world problems.